Welcome to our second week of our awesome mini conference. So in this second week, it's actually our second day of our second week, and we talk about machine learning in production. So yesterday, Jan talked about approaching ML, machine learning and AI projects, about how you can do this from collecting the requirements perspective. So today with Ben, we'll talk about how to avoid complexity, and tomorrow Lina will talk about keeping humans in the loop. It's more about communicating with stakeholders. On Thursday, we will have Duke telling us about search projects and how to go about creating them. And finally, on Friday, we will finish the week talking about the importance of data quality. I would like to say thank you to our partners who made this event possible and advertised it in their channels. So thanks to you. Because of your help, it was possible to attract a lot of people. Thanks a lot. So for those who are watching from YouTube, please subscribe to our YouTube channel to stay up to date with all our events. And then, of course, join our Slack community where we talk about all data-related things. And finally, during today, you can ask any questions you want. There is a link. It's not actually, so this slide maybe is a bit incorrect. So the link now is in the description because in LinkedIn, there is no way to pin a link to a chat. So I put this to description on both LinkedIn and YouTube. So just if you have any question during today's conversation, click on this link and ask any question you want. And finally, thanks to Manning, we have 5 copies of Ben's book, and these 5 lucky people won a copy. So I will contact you and will tell you how to get the book. Congratulations. Now, ready. So today we'll talk about running from complexity, and which means starting with simpler things for our machine learning projects. And we have a special guest today, Ben Wilson. Ben is a practice lead resident solution architect at Databricks. That's probably the longest title of a guest I had on this show. Ben is based in North Carolina, US, and he's doing data science work for the past 12 years in companies ranging from semiconductor manufacturing to fashion companies. And he's working on a book for mining titled Machine Learning Engineer in Action, which focuses on how to get machine learning projects in production and help them stay there. Welcome, Ben.
Thanks. Great to be here.
Yes, it's our pleasure. So before we go into our main topic, let's start with your background. Can you tell us about your career journey so far?
Ooh, one of the weirdest ones. It's even weirder than my job title right now. Started straight out of high school, went into the United States Navy, and went for a program called, basically it's involving nuclear engineering as a technician. So did that for a number of years, got kind of tired of doing that, did a bunch of other things in the Navy, but it eventually exposed me to a position in my last year and a half that I was on active duty, where I was a communications officer, interim communications officer, dealing with message traffic and computers. And it started to fascinate me at just how mind-numbingly boring doing manual tasks in a computer can be. So I started to learn automation of, I'm so lazy, I want a computer to just kind of do things for me. So I started to learn scripting and stuff. That catapulted me once I got out of the military after almost 12 years to get my first job as a process engineer, just dealing with complex manufacturing processes. So running tools and equipment lines and having to craft recipes. Got tired of that company, went on to another company doing a very similar task, but working more in the R&D side of things with emerging products with a much more complex system. And that's where I started to learn even greater tools to maximize my own personal laziness. So I started to figure out, hey, I hate doing this thing so much. It's really complicated. And we had a a contract with a company actually here in North Carolina, less than 10 minutes from my house, the SAS Institute. And they had all these great training programs and allowed us to use their tooling for a fee, of course. And I started to learn the basics of statistical process control and what we used to call as statistics, or the applied statistics, and now we call it data science. Started to learn all that from those great instructors and that tooling. And this is years ago, over a decade ago. But that started me down a path of working for another series of companies where I started to do data science work. Everything from the largest semiconductor factory in North America to a fashion company, which I learned more intense data science techniques and got exposure to Apache Spark. And my current company, Databricks, we're a very relatively early customer of theirs. And I decided to make the journey to learn more about my field and my profession at a company like Databricks. So that long job title is what I call a field nerd. We help companies build stuff, everything from ETL to traditional statistics, applications, analytics, and truly cutting edge, ridiculous, deep learning, distributed ML applications. So that's my career journey in a nutshell. And I've been doing that for just over 3 years now.
Mm-hmm. Okay, so this long title, Practice Lead Resident Solutions Architect, you said it's field nerd.
Yeah.
Okay, so basically helping customers to build what they need.
Yeah, whatever they need. And the topic of today's discussion is highly relevant to that, because that's a narrative that I try to push with teams, particularly when they're just getting into new tooling in particular. And people have a penchant for wanting to latch onto complexity, I think. And they see the shiny thing in the distance. And they're like, I really want to do that, without thinking about what is involved in that and how complex that could be. So one of the things that we do is work with them and say, yeah, that's cool. The shiny thing over there is really fascinating, but let's think about what we're trying to solve here. Let's analyze the process within the frame of vision of who the customer is, our internal customer. What problem are they trying to solve? They just want the problem solved. We're there to help try to solve it. So they're not maintaining code. They're not maintaining a solution. We are. So the simpler we make our lives, and that goes back to what I was saying earlier about my own personality of trying to be as lazy as possible. Laziness is good, I think, in data science and engineering work, because it means you can go and do other stuff because what you built is easier to maintain.
Mm-hmm. So you said you help your customers from everything from ETL to traditional statistics, analytics, and this shiny deep learning new stuff. I guess when somebody comes to you with a request, hey, can you please take this state-of-the-art library or model and deploy or train it, have it for us? Yeah, you probably start thinking, maybe they need something simpler, right?
Or maybe the code that we're looking at is so over-engineered and complex that the solution is, hey, let's refactor this to make it more maintainable. Let's take this, a theme in the book that I wrote that you were talking about is walls of text. And I see that very frequently in data science code, which is, the God function. It's a function that is potentially hundreds, if not thousands of lines of imperative code that is so complicated and hard to follow that the simpler thing is to start breaking it up into smaller pieces. In the process of refactoring that, you can simplify the code, not just in the sense of, yeah, it's easier to maintain, but there might be dead code in there. There might be code that could be handled in a more efficient, cheaper, more understandable way. And that's something that we do on the professional services side, help customers. Sometimes we rewrite the code for them. Other times we pair up with them and build it together. And the end goal is is not just to get something into production, because that doesn't make successful ML. The end goal is to build something together with a customer that they can maintain, that is going to be running in production hopefully for years, and that they fully understand. They can improve it over time instead of having this massively complex code base that if something breaks or they need to, put some new functionality into it, they kind of throw their hands up and say, no idea where to begin.
Okay. So in your opinion, what do you think is the most common reason that projects then don't make into production and fail?
Ooh, so not making it into production is generally one of two things from what I see. One is nobody cares. So there's no business buy-in. You haven't actually paired up with your internal customer to make sure that they're comfortable with what you're building, that they've bought into what you're building, and you've demonstrated in terms that they understand exactly what this is bringing to the table, whatever the solution is. The second one is either picking a solution that you're going to be solving a problem with that's too complicated to maintain or even get to the point where you can run it with stability in production, or it becomes so expensive to run that the return on investment just isn't there. I see that a lot with people trying to apply deep learning to problems that probably didn't need it. And people are like, well, to get my model to train, I need, I have a terabyte of training data. It's, okay, that's a lot. And I need to, get my model iterations faster. So I need a GPU cluster on Spark, and I need Horovod to distribute the training just to be able to get training cycles to work fast enough. And sometimes when you go in and see that, they're talking tech, they're focusing on technical issues that they're having, like, how do I get this to run faster? And nobody's taking a step back and saying, what's the problem you're trying to solve? Oh, churn prediction? Why do you need an LSTM to do that? Like, here's a Pareto NBD model that uses, Bayesian inference to determine what the probability of somebody churning. By the way, I can run that on your entire terabyte of data in less than 5 minutes. Let's go that route. Like, so that's, sometimes people find them at that point mere weeks before they're about to go into production, where when somebody gets the bill from the cloud vendor, they say, why is this project costing $100,000 a month to run in training? The use case is not going to make us $100,000. Turn it off. And that's really demoralizing when a team faces that. So I'd say those are the two most common ones that I see.
Mm-hmm. Why do you think it happens? Why do you think somebody wants to run a complex LSTM using a cluster of GPUs on Spark using Horovod when they need churn prediction? So why things like this happen? Do you know?
Here's a contentious opinion. This is just my opinion, but I think it's people wanting to flex, people wanting to be noticed. All of us are, fascinated by technology, and that's why we get into this field. We want to do cool stuff, and that stuff is cool. LSTMs, deep learning, they're fascinating implementations. The tech is really complex and cool, and it's interesting to use that stuff. It's also really hyped up. Everybody's talking about building cool things with those algorithms. But what people don't understand in this field, or they're not focused on it primarily, and it's something that I mentor people about, is don't focus on the tech, don't focus on the tooling, don't focus on the platform. That's what blogs talk about. You get vendors and creators of open source packages, they're pushing this narrative because they want people to succeed with their tools. But take a step back, and I always recommend people take a step back from what you're doing and just focus on being an engineer. don't try to be a scientist. Don't go into research mode and try to implement a white paper just because you can or because you think it's a cool thing to do. Think of applying ML as an engineer would. The parallel, or the corollary that I use when I'm talking about this is bridge building. If you're talking about building a bridge across a 20-foot gap, a scientist may approach that and say, "Hey, we can construct this bridge out of carbon nanotubes, and we can have, ultra high weight, molecular weight polyethylene wrapping around these carbon nanotubes, and we can make a bridge that weighs less than a car that can support the space shuttle, and it'll work amazingly well." An engineer would never even attempt to do something like that. They're like, this is going to be ludicrously expensive, and it's going to be, we're going to have to do all this research to figure out how to even do that. And we're going to have to build tooling in order to support the construction of the materials to make the bridge out of. An engineer is going to say, no, steel's good. Like, we've done this for over 2 centuries, building bridges this way. Some engineers that are more Luddite type that might say, no, we can just concrete and rebar. Let's do that because it works. It's a 20-foot gap. Let's build the minimum required complexity in order to support this. And let's use proven techniques to solve the problem of getting cars from one side of a hill to another side of a hill. And I see data science works the same way. When you're working as a professional in a company, in an ML team or a data science team, we're there to solve problems. Nobody cares how we solve them. And solving it in proven ways that are consistently proven to work is the more wise decision. That doesn't say don't play around with the cool new stuff. Just do that on your own time. That's what a lot of us do, have been in the industry. I'm sure you do it as well. Some new cool tech comes out and you're like, I'm going to try that out this Friday evening or Saturday morning. I'm going to block 3 hours. I'm going to play with this new tech. But generally you don't do it when you're working on a project for a company. That's a fast ticket to get fired, if you're experienced.
But I guess other problem could be that maybe somebody hasn't done this problem before. So maybe they don't have experience. So they start looking things up, and then they see LSTM here, LSTM there, like all these transformers, and okay, maybe I'll just go with this. And then when they need to train it, they see that, okay. And you mentioned this method, I don't remember the name, like the more traditional one, Bayesian one. I haven't really heard about this, to be honest. So when I Google things, and so I see, okay, this is LSTM, and this is some thing I never heard about. What do I choose? And then maybe people end up with these complex solutions.
Exactly. Search engine optimization creates technical debt in data science work. So what I always recommend, and what I've always done, is if I'm working on a new project that I have no experience on, and newsflash to the viewers, even people with 12, 15, 20, 30 years experience in ML, you're still going to find that constantly. Our industry or our profession is so broad in the amount of things that you could possibly specialize in. Nobody's going to know it all. I'm not an expert on NLP, but I know people who are experts on NLP. So if I'm working on an NLP project, I'm going to go talk to them. I'm like, hey, if you were going to, if I'm talking about a customer project, I'm going to anonymize it. I'm not going to say, hey, I'm working with this customer, but I'll say, here's a problem that I'm trying to solve. And here's the expected outcome. This is what the customer, the internal customer, wants to see out of this. How would you solve this? And then I'll ask a couple other people. Maybe I'll assemble a group of experts, and the communities that we have that you've built, and some of those other communities that you listed at the beginning of this, there's amazing talent globally of people that are just willing to come together and help each other out, because we all struggle with every bit of this about knowing, where do I even begin? If I do a Google search for how to solve this particular problem, I know that the first couple of pages are probably going to be hype. They're going to be a lot of blog posts that are sponsored by companies that might not be the right solution. And some of the original research of maybe perhaps the best way to solve it or the simplest way to solve it, it predates the internet by so many decades, if not centuries. Bayesian methodology. This stuff is 19th century. A lot of the research was done. The original papers that implement this stuff predates computers. So finding those resources of knowing, like, hey, how would I deal with a non-parametric distribution if I'm trying to estimate, this prediction? It's highly esoteric information, and it's really hard to find when you're just searching on the internet. It's much easier to join a community and just ask people that may have done it before. Send out a flare, and some of these communities, everybody's so helpful. Somebody will chime in and be like, "Oh, I solved that same problem before, and here's what I used." You'll still get some people to be like, "Oh yeah, use deep learning," but you might get somebody who's, kind of been there, done that, and is a little older, more experienced. They'll be like, no, you can solve this with this statistical inference method that's really old, but it's really powerful and fast. And yeah, that's how I approach that to avoid that trap.
That's maybe something I'll use as a pitch for DataTalks.Club.
Definitely, you
Some
should.
of your words. Thanks. And the other reason of why projects don't make into production, you mentioned that nobody cares, there is no buy-in. And then you also said that we need to focus on being engineers. But sometimes I think when we focus only on being engineers, sometimes we get into this trap of we have this tool, let's try to find the solution for this tool. When we're isolated from, let's say, from business people, from business units for who we solve this. So how dangerous is it when we become isolated and work on machine learning projects?
Silos of data science is the fastest track that you can have at a company to never getting any of your projects actually used. They may be in production, they may be running every hour on the hour, but the chances that people are actually getting value out of that is going to be super low if you're not involving yourself with the business. I see the modern data scientist as, people think of it who are coming from a post-grad research position. That is highly isolated. You're on your own doing your research. You're using the scientific method to prove a point or to come up with some conclusion of original research. When you come into a business environment from that, it's like night and day. Some people want to default into what they're comfortable with, which is isolation, siloing off. Hey, I only speak in the terms of data science and mathematics and physics. The rest of the business doesn't speak like that. Some of them don't understand that because they don't need to do their jobs. And that's not what drives the company. There are companies that are driven by that, but they're relatively rare. So an important message that I always have for data scientists coming into the field is you have to work on interpersonal skills. You have to get to know people, know how to build a relationship with them in the business. You don't have to be their best friend, but getting to a point where you can have a frank and open, honest conversation with the business unit and say, how can I help you? And how can you help me make this better? That collaboration is super critical for any project. And that's where you're going to get all of your best ideas anyway. A model is going to produce some output, whether it's supervised or unsupervised, deep learning or traditional or statistical. It's going to produce some numeric output. The chances that numeric output are going to be perfect for the business use case are slim to none. There's usually some post-processing that you need to do, some decision engine that you have to run that prediction through. All the logic of that comes from the business, from the subject matter experts. They're the ones that are helping you do your QA, hopefully. They're the ones that are saying, hey, data scientist, this is good, or hey, this sucks, and you need to completely change this. the earlier and the more frequent that relationship is built and nurtured and maintained, the more successful every project's going to be, because you're customer focused at that point. You're really thinking about that internal relationship of, regardless of who's going to use it, having them involved is going to not only make the project have a higher probability of making it into production, but it's also going to make the project simpler, because you have to explain what you're building to them, to a layperson. And they're like the ultimate rubber duck in that sense. You're explaining through what you're building, because they're going to ask questions like, well, how does this work? If you can't explain that to them, it's probably too complicated. And it's going to be a nightmare for the next person that comes into the team to maintain that if you can't explain it to the business. Mm-hmm. So I always see it as a win-win. The closer that relationship is between the data science team and the business, and silo walls need to come down if you want to be a successful data science team.
Why do you need to explain something to business? So why do they even care how this thing works inside? So I can say, hey, just give us your data, then we do some magic, then you get the output, and trust us, this output is good. You can use it. So why do we need to care about, okay, they understand or not? Like, why do
they're going to want to understand? If why? You build that relationship correctly, and they're emotionally invested in this project, which is the goal of the data scientists working on it, you got to get them hyped up about it. And they're going to want to know. Humans are naturally curious. If you show them a little peek behind the curtain, they're going to want to step right through that curtain with you and say, hey, I can't speak in your terms, or I don't want to hear the nerd talk, but explain it to me like I'm a 5-year-old. And that, even though that is kind of an insulting phrase, but explain it to me in terms that mean something to them in the context of the business and the problem. Because even though they might not understand how we discuss data science work, we don't discuss in the terms, we wouldn't understand how they talk about what they do and their understanding of the business. So it's a partnership of, you have, like, those people have expertise in how the company is run, or how finance operates, or how sales operates, or operations. Lean on them while they lean on you to both jointly understand the project, and explaining it in a way that you both understand fluently is going to make sure that help ensure that the project is more successful.
Mm-hmm. So basically, if you can explain to them, if they can understand, then yeah, maybe they will also have more trust in what you build, right?
Yes. So, and they'll come up with ideas. That's some of the best ideas I've ever had for any projects throughout my career have always come from those subject matter experts. It doesn't come from my head. I think of crazy stuff that it might seem like it makes sense looking at the data, like, oh, there's a correlation here between, this, value in this, and then show that to the business, and they're like, what are you talking about? Those have nothing to do with one another. I'm like, oh, so what is important? And they're like, well, you might want to think, oh, I didn't know we collected that data. Let me bring that in. Oh, wow, that just made the model like 30% better, and it actually solves a problem, and it's simpler. I can do that in SQL. So it's super important.
Mm-hmm. So basically, we need to involve subject matter experts as early as possible. Then we need to get a buy-in, and then we need to make sure that our model is not as complex, so we can actually safely productionize it in such a way that we can maintain it afterwards in 1 year, in 2 years. It's not too expensive, right? So then we see the value, right?
Right.
So how do we go? How do we go about this? So let's say we have some project idea. So how does it look like? How do we go from the idea to production in such a way that we maximize our chances at the end to be in production and have something that is maintainable?
Ooh, you said we have an idea.
Or somebody comes to us and says, hey, there's this awesome thing. If you do this, our company will have millions. Or it can be coming from a data scientist, doesn't matter. We just have an idea, somebody of us.
Yeah, I find it different if it's a subject matter expert engaging with the ML team, because they already have the emotional investment. It's their idea.
Mhm.
They're going to actively want to work with the data science team. And it's in that relationship, it's on the data scientists to maintain openness, to support that collaborative discussion, and include them in all of the testing that's done and all of the validation and all the way up until production release and after production release. But if it's the data science team coming up with the idea, you have to sell that. You have to get that buy-in, and getting that buy-in means immediately after you do your first rough experiment. And I always say to time box these things. You have this idea like, oh, if we could only classify cats and dogs better, then our company is going to make millions of dollars. So we need to build a CNN that we can detect these. So we need to test out a mask R CNN, and we're going to use TensorFlow and Keras to do that. Cool. Take 2 days, block it out on your schedule to try to build a rough prototype. And that can just be nasty script code in a notebook. Just get something that does kind of what you're thinking, so that you can produce an output that you could put into a presentation and sell it to the business. Don't spend months working on one of these skunkworks projects that you want to get it to perfection before you show it to anybody. Be very open and honest and say, hey, we only spent 48 hours on this, or we spent a week on this. It's really rough, but here's our concept. And at that point, you have to go into business selling mode. You have to say, here's what we're proposing. Here's how we're going to do it. We think we have to do some experimentation, but here's the general idea. Here's what we believe our company is going to get out of this, and then sell it to. I always recommend to sell it to the business unit that cares most about that data, or who owns the data, owns that business process. Sell it to them first before selling it to executives. Because what you don't want to do is have a high level elevator pitch that an executive buys into, thinking that this is going to be a panacea to all the company's woes, and then talk to the SME team later on, and they're like, what are you guys doing? This is nonsense. This is not going to work. So talk to them first, the people that know, the boots on the ground. And once they say, yeah, this is awesome, we're on board, we'll totally support this, we'll work with you to make this good, then pitch it to the executives. See if you get a buy-in. You need some sort of executive sponsor, because these things, most ML projects are expensive, from not just computationally and hardware and VMs and stuff in the cloud, but also just time and effort. There's so many other things you could be doing. This one had better be pretty important. So if they sponsor it and say, yes, this is good, this is where we want to go, then it's constant involvement of that SME group, from the pre-ideation phase to the planning meetings that you're doing, to say, what do we need built? How long do we think this is going to take to do these different phases of this project? What are we going to test? When's our next meeting? When's our presentation cycle? And once that's all formalized and understood, go off to do 2 weeks of experimenting. Like, hey, we're going to try out these 5 different approaches, and we're going to split the team up. Each sub team is going to do one of these things. And then we're going to have a bake-off internally. And then we're going to have a bake-off in front of the SMEs. And they're going to say, oh, we really like number 3 there. That's super awesome. And then you present them the cost benefit analysis of each of the approaches. Like, hey, number 5 that we tested, it could be 10 times cheaper than number 3, but 1% less accurate. Well, what's the trade-off there? How fast can we get it out? How easy is it going to be maintained? And do that analysis beforehand to have that ready for the meeting, and then make a group decision. I don't ever recommend the data scientists are the ones making that decision. We're there to provide basically the scientific evidence of what the results of our experimentation are, and then let the business decide, like, oh, if this is cheaper and faster, we want that. Business might say, no, we really care about accuracy here. We need you to build this. Then go and build it. But periodically, in sort of ML agile approaches, I always recommend that throughout that development process, after experimentation and this decision is made, each one of those sprints that you conclude, whether it be 2 weeks or 3 weeks, you should have a working version of whatever you're building. push for that basic MVP at every time, every sprint conclusion. So when you cut that feature branch and merge it to master and run everything and get the artifact as well as a bunch of demonstrated predictions, that's used as a presentation for the business at a meeting. Say, here's the status right now. What problems do you see? And they might say, well, you're supposed to be predicting cats and dogs, but we threw a penguin in here and it says that it's a dog. So there's a problem here. So show them that, show them the results, get their ideas of what to test. And eventually, by the time you hit production readiness level, the model will be good. It'll be good to solve the problem, but it'll be good because the SMEs have faith in it, because they have skin in the game. It's their ideas in code being shown. They're going to want to see it succeed. And that's that inclusive aspect with the business that becomes so important, because we're emotional creatures. So when you get somebody who has ownership of a project, even if they're not the one writing the code, they're going to want to see it succeed, and they're going to be the champions of it, and they'll use it and they'll help make it better. And that's how you make successful ML.
And SMEs are subject matter experts, right?
Yes. Yep.
Whoever
the geniuses are for that domain.
Mm-hmm. I heard this thing called IKEA effect. Maybe you heard about this. So
IKEA effect.
Yes. So like in IKEA, you buy a thing, but it's not assembled yet. So you have to assemble it yourself. And it's pretty simple usually, like they have an instruction. So let's say you bought a desk, then they just, there is a very simple instruction that was tested on many, many people. So you just put this together, and at the end, maybe you have this ugly desk, but you really love it because you build it yourself.
Uh-huh.
So you develop this kind of attachment to this table. So because you bought it in a pack, you developed it yourself, you build it yourself, and then it's standing there. You can maybe put your laptop there, or I don't know, eat from this. Maybe it's not the same quality as if somebody would build it for you, but you love it.
Definitely. I think that's a perfect analogy. And I think there's a difference with that effect if you're buying that desk and it comes in 10 pieces versus that desk that comes in 10,000 pieces.
Yeah.
So you're going to love the 10-piece desk, no matter how boring and simple, and it might not be fancy, but it gets the job done. You're going to love it because you helped build it. The 10,000 piece desk that might be made out of some rare wood somewhere and rare earth metals, and might be super fancy, but it costs 10,000 times more than the simple desk. You're going to be emotionally attached to that, but that's not a healthy attachment, because you're going to have everything invested in that, and you're going to be stressed out about how complex it is. And when it breaks, you're going to be trying to fix it because you built it. It's your baby. The whole company can be in that mindset too. And I do see that with certain companies that I've interacted with, where they've built that 10,000 piece desk. They love it, but they also hate it because they can't build any more desks. They can't build the chair that goes along with it because they're too busy fixing the desk over and over and over. That's the whole data science team spends 90% of their time just fixing and gluing back on little pieces that keep on falling off.
Yeah, I remember I once bought something not from IKEA, but from other store. It was a German store, so I had high expectations in terms of simplicity, like how simple it would be to collect or to build the thing. But it was not like, it wasn't as simple. It was more complex, and I hated that thing. And then I think I gave up. Like it's still in the basement, not assembled. So
yeah, that can happen with ML as well.
Yeah. So let's say we have something more complex, maybe a novel algorithm that we want to try. Right. So we hear like right now deep learning is very popular. So we want to try it for our problem. Should we do this? What like, is this necessary? Like, what kind of risk we have for doing this?
I'd say proven deep learning algorithms. If we're talking about CNNs, if you've got an architecture that somebody has spent time building and has proven out that it actually works, I'd say it's pretty low risk. That's the benefit of transfer learning. You can say, oh, I'm going to take Inception v3. I'm going to lock the first 90% of the layers for non-training, open up the last 10%, add on my own classifier stage and retrain it on my data. Fairly low risk because thousands of people are doing that. I've done it dozens of times. It works. Building something from scratch where you find a white paper, there's novel algorithms. That's where the risk comes in. When, and I'm guilty of it myself, of not only implementing those, but also creating them from scratch myself.
It's fun, right?
It is very fun, but it's important to make sure that there's not a solution out there that does what you're trying to do in existence. A lot of things that get published, particularly in our field, a lot of people need to publish because this is a burgeoning, growing field. And there's a lot of exciting research being done. There's also a lot of non-repeatable research being done. There's a lot of stuff that gets published that even if you were to try to re-implement exactly what they did, even if they show code, which most of them don't, but sometimes they will have a GitHub repository, like, hey, check out the code that I had for my research. And you take that code and you run it on the exact same data set on a different environment, and it doesn't work. It doesn't produce the same results. It's dangerous. So what I usually recommend if somebody's thinking of implementing novel algorithms, check to make sure it's possible. See if other people have done it. You don't want to be the guinea pig unless you've established street cred at your company. And what I mean by street cred is you've already done all low-hanging fruit. You've got dozens of models in production solving actual real-world business use cases at a company. If you're working for an e-commerce site, you've got CLV, you've got churn, you've got fraud prediction, you've got RLV, you've got RFM clustering, you've got recommendation engines, you have targeted messaging for marketing. You've got all these models that are currently running and working and doing great. And now you're out of the easy stuff. You're like, oh, I don't know what to do next. The business wants us to do this really crazy thing that I spent 2 weeks trying to research how other people might tackle this. I've talked to my people over in DataTalks.Club. I asked a couple data scientists saying like, hey, has anybody tackled this? And the only response that I got was good luck, or hey, that's NP complete. We have no idea how to do that. If you've gotten to that point, that's when you're going into the white paper zone of saying, hey, maybe somebody's done research, or maybe I can actually contact a university and see if any other postgrad researchers are working on this problem, and try to assume that risk if you have no other option. But the important thing to do there is communicate to the business and your management, and probably all the way up to your CTO, of how risky this is. And if everybody's on board saying, yes, this is the direction that we want to go, put on your research hat and figure it out, that's when you're doing novel work. And maybe publish your results when you're done, help out somebody else in the future, because we are that sort of community. But if it's a problem that has been solved by somebody some way, or particularly problems that have been solved by many people over many decades using what some people might think of as uncool tech, like, oh, I don't want to use stats models in Python. I'm like, oh, I want to use machine learning. It's like, everything is stats in what we do. So what's wrong with statistical inference? Like, just learn about it, use it, try it. If it works, great. You just made the business happy. You solved a problem. Now you get to move on to something cool or cooler. That's kind of how I see that, the original research.
So this is how you earn street cred. So by doing uncool stuff first, by not using machine learning, maybe using the stats model library before even moving to scikit-learn. And then eventually you maybe get into this area where no one has solved this problem before, and then you start figuring out how to do this.
Yeah. And even before the stats packages, there's a shocking number of what people would classify as data science work or ML work that you can solve in SQL. There's plenty of things.
Right?
Yeah. Quantile bucketing, windowing operations, building linear equations that you can say, hey, I just need to interpolate this point between these two other points in order to provide an inference. It might execute in seconds versus the ML approach, which could take an hour of training and then 10 minutes of validation and all of this code that you have to maintain. Whereas if you can solve the business use case with simple SQL statement, do it. We're here to solve problems, not to get fancy.
And I think what you mentioned is you can see at how many people have solved this previously to understand how risky it is. If thousands of people have done this, like this transfer learning CNN example, then it's low risk. Like tons of resources, you can maybe do this with your eyes closed because you did this 12 times already. But if it's only 10 people who have done this and they are the authors of a paper you're reading, then yeah, maybe it's a lot more risky, and you should try to solve other easier problem first before doing
and if those 10 people publish something, check to see how many other papers reference that paper. That's always something that I do. I learned that the hard way several times. I'm like, oh, it's published by this university, they definitely know what they're talking about. And then try to implement it or take the actual code and try to run it. Like, wait a minute, there's an issue here with how this works. Or they did it in a language that you can't transfer it easily to another language because of, floating point precision or something. And you're like, oh, geez, I would have to re-implement how this particular package that I would require to interface with does its calculation here. So now I have to write my own core mathematical algorithm to support this algorithm that I'm now building on top of that. It's turtles all the way down when you're in that space. And I do sometimes see that in certain customers, like Databricks, of course, the company I work for, is the creators of Apache Spark, so distributed computing. A lot of large scale ML use cases people put on Spark because it can support truly ludicrous amounts of data. Not every algorithm is distributable. So I've worked with people before who are like, hey, we need to do non-negative matrix factorization on Spark. I'm like, okay, well, we have ways of doing matrix inversion in Spark through an iterative process. And they're like, no, we can't use that. We need to actually invert the matrix all at one time. Like, that's going to shuffle all the data to every other executor. This is going to be super expensive, and you're going to need this massive cluster that can handle this. And they're like, well, we read a paper, and it's like, okay, you read a paper on somebody doing this. Let's give it a shot. We'll give it a week. We'll play around with it, try to write some code. And then later on, you realize that, oh, the reason it worked was because the Hadoop cluster that this was running on, that had Spark running on it, had 10,000 nodes available. This company can't afford that amount of VMs to be started in their AWS instance. So we had to backpedal and say, we can't do this, and here's why. So it's important when looking through those papers to read the fine print and then see if other people have been successful in doing it. And that's actually what I found a week later, was other people referencing that paper saying, yeah, this is cool, but this was the environment that they ran this on. So unless you have this amount of horsepower behind you, unless you're Google, maybe not do this.
Yeah, I think I saw something similar. So there is a company called Criteo, I don't know how to pronounce. They actively use Spark. They have I don't know if they still have their Hadoop cluster, but they were they like the fact that they have like the largest Hadoop cluster in Europe. And yeah, so they would do a lot of talks like this, but maybe for smaller tech companies, not all these things are as easily implementable as for Criteo, because they have this Hadoop cluster and they don't. I Didn't realize we have so many questions. We have actually 6 questions. So Razona says that my impression is that a lot of companies slept through needing people with basic stats skills and now are throwing data science at it. Do you agree or disagree?
100% agree. 100%. I think there's 2 core critical skill sets that some companies don't realize that they need to make successful data science or ML use cases. The first one is statisticians or people with a statistics background. It's such an important aspect of our work that we do. You don't need everybody to have that background, but you need at least 1 or 2 people to really understand statistics at a extremely deep level. And the second one is coders. Get a developer to train up the data science team to create ML engineers. And I know that term is thrown around a lot of people like, well, ML engineers do ML ops stuff. What I mean by ML engineer, my own personal definition, is the data scientist who can code. Somebody who can do soup to nuts. Like you can do the ETL and you can deploy to production, everything in between. And having a statistics background, as Razona said, is also super critical as part of that. Even if you're not an expert, you should have exposure to that and do continuing learning on sometimes reading the old school textbooks that were written far before digital printing was a thing.
Yeah, I think I had one of those textbooks. I tried to read it and it was so difficult.
Yeah, some of them are pretty dry and pretty complex, particularly the pure theory ones.
Yeah.
The alternative to that is wait for you to write a book about translating that. There's a lot of people writing books like that. They're like, hey, here's the foundation of this like crazy technology in theory, but let's talk about it from an application standpoint. And that's really what people need to know. But having somebody who understands the theory is also helpful.
Yeah, thanks. So a question from chat now is, could you please advise how to structure an agile Scrum team specifically for machine learning or data science work? So my experience says that the typical software Scrum doesn't fit well to data science. But I think the example you gave was very similar to Scrum in a sense that every 2 weeks or every end of sprint, you have something that you can show to the stakeholders, to subject matter experts. And every time you finish your sprint, you have a working thing, which is very Scrum-like.
Mm-hmm. Right? Yeah, and people don't like to hear that. Teams that I've talked to are like, we can't do that. That's not how we work. It can be. And it's about iterative development in ML. And the only way to make that successful, to have that Scrum mentality, follows along with what we've been talking about today, is you have to keep it simple. It has to be lightweight. It has to be just barely functional at first. But the Scrum mentality of having buildable, usable, executable code supports you in keeping the complexity down during that development, because you're not going to have enough time. And that, by the way, that's why software developers do that as well. And you know that you come from a software development background. If you're just left to do whatever you wanted to do, like, hey, the project is like, come back in 6 months and we'll show you, show us what you've built. You could build some of the most unmaintainable, crazy code that's so over-engineered that it meets the requirements, but it does 10,000 things that they never asked for. So that's why you do that Scrum process of saying, just build what you really need to hit the target for this sprint. And you can do that with ML projects, but it involves building like very bare bones experimental code that goes into that MVP process where you're just building on iteratively the new functionality. You might say, we just want like the data to be loaded somewhere, and we need to do some just basic feature engineering. Let's get the feature engineering work and run it through this placeholder model. That placeholder model doesn't have to be an algorithm, doesn't have to be ML. It can be an if-else statement. It can be, a simple linear model that is coded, like hand coded, by taking your feature vector and passing it through just offset weights that you're applying. Keep it as simple as possible. And then once you get the feature engineering all worked out so that you can create a feature vector, maybe the next sprint is, all right, we know which algorithm we're going to go to. Let's build all that code out, and let's tune all the hyperparameters in an automated way. Let's use Optune or HyperOpt. That's this sprint. At the end of that, you still have a result. You have predictions that you can show people. The next one might be, all right, now we're doing unit testing. Let's unit test all that feature engineering code. Let's write all those tests. Let's make sure that we have an integration test from ingest to prediction. So it's possible. I know it's possible because I've done it many, many times.
So the main concern I hear when somebody is saying, hey, let's use Scrum for research, is that research is very undeterministic. So you don't know if something you do is going to succeed, to be successful or not, right? But yep. I think it's still a good idea to time box this thing. So yes, you'd rather spend 2 weeks to conclude that it's not possible rather than you spend 2 months or more to conclude that it's not possible, right? So it's still a good idea. Right?
I hear that from people all the time. I've gotten that as feedback from the book, the first couple of chapters. People are like, well, how can you tell in just 3 weeks whether something's going to work or not? Like, maybe you can't. Maybe if you spent 3 years working on the problem, you'll figure it out and you'll get something that's workable and stuff. But as data scientists, companies aren't expecting us to do original research generally. Some are. They want a problem solved. And it's not just the problem that you're working on right now they want solved. They probably have 100, 200, 1,000 problems they want solved. If you're not time boxing that research and saying, hey, we're gonna either shelve all of our research for a later date so we can work on something else, or we're just gonna say, hey, we've given it our best shot and we've tried it out. We can't figure it out. Maybe we need to hire somebody with experience in this field. Maybe we need to, have more discussions in the community and say, hey, how do other people solve this? That might take time. But if you have that time box, you can now move over to another project while somebody's taking a couple of hours a week of just continuing that research phase, but not devoting an entire team to try to figure something out over months.
Yeah, there is another question from Razona about your mentoring. I don't remember if you mentioned something about mentoring during today, but is it a formal thing or something through Databricks?
I do a number of different things, but for mentoring, we have programs at Databricks that we do that. We have several for software development, where we have people in the field that come from a data science or statistics background that are trying to learn how to get better at software development skills. So there's a bunch of programs that we do like that, which are formalized meetups and project work. So we allow people to learn in the best way that they can, which is learn by breaking it and then fixing it. We also have programs where we're teaching people from a data engineering background and a software development background, ML. There's a kickoff that we're doing that we just started this week actually for the next round, which is formalized at the end with a capstone project. And that capstone project is full end-to-end production ML, which is, this is unit tested, integration tested, monitored with A/B testing built around it, deployment, CI/CD, like everything that you can think about from production ML. That's what we help somebody build. So they focus on solving a problem with an open source data set.
No, thanks. So I know we should be wrapping up, but I also want to ask you about your book. Maybe you can tell us a bit about this and how is it related to the topic today?
I think everything that we talked about today is covered in the book in some way, and then another 610 pages on top of that. So yeah, it's kind of a monster of a book. But yeah, the first part of the book is talking about process. about how do we think through a problem? How do we have those conversations with the business? How do we do that Scrum implementation from ML and talking about what is actually important about solving problems, and how do we engage with people to help collectively and collaboratively solve those problems. Section 2, part 2 is more focused on implementation of esoteric things that a lot of people don't focus on. It's not the fun, cool stuff. Like people really like reading books about like, hey, how do I build an algorithm? And that's key core data science work. You need to know how to build your random forest or your logistic regression, or how to implement a statistical model. But so many people have written books about that. I wasn't interested in writing that. In fact, what I normally do is, hey, go read Alexi's book on how to do this. If you want to see it in applications of ML algorithms and the explanation of how to do that, I'm focusing more on how do you automate away the annoying part of that, which is how do you do automated tuning when you have 1,000 time series models that you need to predict? How do you automate that? How do you distribute the training and auto tuning of each of those? And then what do you do with them? How do you produce visualizations that are not specifically for data scientists? How do you produce a visualization that tells a story to a business? And then part 3 is more the development stuff. Like, hey, why is code quality so important? Why is testing so important? Here's how to do this type of stuff. Here's some gotchas that I see, because I'm kind of spoiled being a consultant at a pretty big company. I interact with a lot of companies, so I see how a lot of data scientists do stuff. And there's repeated patterns that I see. So I just try to address those. Like, hey, think about computational and space complexity. This is why it's important. This is why code quality is important. This is why modularity, abstraction. Like, if you're not doing these things in your ML code, it's going to be a nightmare to maintain. That's pretty much the book. It's all the stuff that people usually don't talk about ML.
So you said 600 pages, or how many?
Yeah, something like that. Okay. They're trying to get me to make it go down.
Yeah, I know what you're talking about.
It's going to be so expensive to print.
Do you have a couple of more minutes, because we have 3 more questions?
Sure.
Okay. Yeah. So one comment from Akshat, or question. So it makes sense to solve problems with Uncool techniques, but there are companies who are, I would say, AI first. They want to show off and say that they have AI capabilities. So what about them?
Good luck. I mean, you're going to have to spend for that talent. And that's, I'd say, less than 5% of companies that I'm aware of or that I've interacted with have the budget and the resources to acquire and retain that level of talent. So if you're an AI first company and all you want to do is the most cutting edge, most complex implementations of things, that's great. More power to you. I just hope you have the budget for each of those people. You're going to need what they call full stack data scientists, or what I call ML engineers. You're going to need people that have been there, done that, and know how to do that complex implementation, or can build novel algorithms. And they're not cheap. Here in the United States, at least, you could be looking at having to pay somebody $500,000 a year in salary who knows how to do that, who can successfully do that. But most companies don't have that budget, or they see that price tag and they're like, whoa, wait a minute, that's more than we pay like our senior staff developers. No, we're not going to do that. We're going to hire people straight out of a PhD program, and then we're just going to tell them to do this. Good luck. Like, it's not going to go well. Those people are probably going to quit because they're going to be under so much stress. They're not going to really know how to do all of that. So you need the right talent. You need to bring in the new people so that they can train, but you need to have processes built around mentoring and cross training, pair programming. Yeah. All I can say is good luck.
Yeah, right. Thanks. The comment from Anonymous is, I always hear about data scientists having to explain their managers things in simple language. Do you think it's high time that managers have a crash course on data science?
I think it's important for a data scientist. I think it's important for any engineer, software developer, from a front-end software developer all the way to, an ML engineer. Anybody who's working with tech that is esoteric in nature, you should be able to explain it to your parents or to your children or to your spouse, or you should be able to explain what you do and how you built something in terms that any human who has sufficient understanding of business operations can understand what you're doing. Now, that's not the question that was asked. It's, should my manager be able to understand terms in what I'm doing? Yes and no. I mean, it's up to the tech lead, I think, whoever the most senior data scientist is, to work with that manager and educate them. Say like, hey, when we're in our stand-ups and we're talking about these things, this is what that actually means. I've done that at companies I worked for in the past. I don't have to do that at Databricks because of what we do and who we hire, but at previous companies, yeah. Sometimes the managers doesn't want to ask, or they're saying, hey, I need this explained in these simple terms. It could be because they are afraid to ask what somebody is talking about in a meeting. They don't want to look like they don't know what they're talking about. So the tech lead should be the one telling them like, hey, I'm willing to teach you all of this stuff so that you can follow along exactly with what the team is talking about. They'll probably be grateful. And if they get angry at that, then maybe your company sucks and you need a new job. Like, I mean, I would extend the olive branch to that manager and say, hey, do you want to learn more about this? And every single time that I've had that interaction, they're usually so grateful. And they're like, oh, this is amazing. This is exactly what I was hoping for. Can we meet for an hour after work? I'm like, yeah, let's create a cheat sheet for you. That's, here's this concept. Here's what it actually means in layperson's terms. And people that I've worked with in the past have filled multiple pages front and back with that translation. It's their Rosetta Stone to talk data science nerd talk.
And I think it's not reasonable to expect from a manager that if you just send them a course of Andrew Ng or somebody
No.
else, that they will do this. I don't think they will ever do this because they are busy. Right?
Yep.
They're busy with planning, budgets, and hiring at I don't know, a ton of things. They're just too busy for learning machine learning, right?
Mm-hmm.
So, and it's not their core competency. So
Right.
it's your job to educate them, to tell them, okay, we mentioned this thing during the stand-up. This is what it actually means.
Yes.
Right. Okay. Last one. So from Chetna. I've often heard people suggesting that to be successful as a data scientist, one should find a niche, for example, become an NLP expert, recommendations expert, etc. What are your thoughts about this?
Depends on what you want to do with your career. Some companies will only ever do one thing. If you're working at an e-commerce site, you'll be exposed to a handful of algorithms that you'll be working with. If you go and work for a social media site, you may have some overlap of those fields of speciality, but there'll be additional ones that'll added, and there'll be some that won't be done. If you go work for CERN in the south of France, you're not going to be using any of that stuff. So there's differences between, pure scientific data science work and, commercial data science work. It really depends on what you want to do. But what I always recommend is get really good with the core basics of data science work. And what I mean by core basics is Bayesian modeling. You don't have to be an expert in it, but know how those things work, why to use them, when to use them. Learn ensembles. Like when I say learn ensembles, I don't mean learn how to apply an API. Anybody can learn that. I mean, learn how a decision tree is built. why it's built that way, what the hyperparameters do. What does that mean that your feature vector has to look like? When you move on to from decision trees, how are random forests made? Like, what does the code actually look like for constructing that? And then everybody should know how linear systems, like generalized linear models, should understand how they optimize, why they're built the way that they are, and what all those hyperparameters do. And once you have that as I think every data scientist should strive within the first 2 years of their employment to become experts in those 3 areas, and then move into growing that knowledge with advanced statistics of statistical models, like how do time series models work? You don't have to know all of them. There's dozens and dozens of them, but know a few of them. And then as you're moving in knowledge from that, that's when specialty usually happens. 4 or 5 years. I don't know, Lexi, would you say that's about right? 4 or 5 years is when you start to specialize. So. If your company's working on NLP, you may become the NLP guru. If you're working on computer vision problems, you may become really good with OpenCV and TensorFlow and Keras with CNNs, and that might be your bread and butter. If you want to do that, and that's what you're passionate about, yeah, go all in. But when you get to the 10 to 15 year mark as a data scientist, I find most people branch out and try to become a specialist in another field as well. It's just good for career progression to be able to mentor more people and be able to contribute more to different problems. And it also paves the way to what I expect eventually will become more ubiquitous, which is like the chief AI officer or chief ML officer at companies. Like, that's the sort of the pinnacle of a career growth for people if they want to stay in the field. You have to know how a lot of different things work.
And you probably can still be successful as a data scientist without specialization, without a niche.
Yeah, generalists work really great. You don't have to have the ability to implement, some package from scratch from memory. Like, having that level of deep understanding of something, that's not required. Some nerds like myself are like, hey, I want to create a new algorithm that solves this problem, where I want to port, single node or single machine algorithm to a distributed system. I just find stuff like that fun, so I do it if customers have a use case for it. But you don't have to go into that level of specialization. You can be a generalist and say, yeah, I know how to build NLP models. I know how to do association rules. I know how to do collaborative filtering, and I can implement XGBoost on any problem that you have, and I know how to tune that properly, and I know how to monitor that. Yeah, generalists are pretty successful.
Okay, thanks. So let's finish. How people can find you?
LinkedIn. I'm also a new co-host to the podcast on DevChat TV, Adventures in Machine Learning. You can hear me ask a bunch of people. You've been on that show, actually.
Yes.
And we're probably going to have you back for another round.
Yes.
And so yeah, come check me out there. Find me on LinkedIn, and yeah, check out the book if it sounds interesting. And it's in early access, and I think it's getting published in November is the plan right now. So yeah, you can buy it now.
Okay, cool. Thanks a lot for joining us today, for sharing all your knowledge, and thanks everyone for watching us and asking questions. And do remember that we have 3 more talks this week. They're all amazing. Check them out if you haven't, and register for the remaining events. No, that's all. And thanks again. It was nice chatting with you.
Yeah, it was nice for me as well. Thanks, Alexei.